Hey students, I thought I'd make another video here. This one is again from chapter 28. It's number 29. And again, it has to do with adding velocities. And so let me point out again, if you haven't seen this, that I made a little video on trying to organize your thoughts about what is u prime, and what is v, and how to kind of tackle these relativity problems. So if you haven't already read that, you might want to, or watch that one, you might want to watch that one. It points out a couple of interesting things, which I'm going to do here. All right, let's try this problem. It says, what is the relative velocity of two spaceships? Okay, so we got two spaceships. If one fires a missile at the other at 0.5 c, and the other observes it approaching at 0.95 c. Okay, so maybe I'll make two spaceships. Here's spaceship 1. Here's spaceship 2. And it fires a missile, so maybe I'll put a little missile here. And so hopefully you see these three different speeds. There would be a speed of how fast is the missile going away from ship number 1. How fast is the missile approaching or separating, depending, ship number 2. And then how fast are the two ships separating? And that's the question. What is the relative velocity of the two ships? So this is the unknown in the problem. And it says here, if one fires a missile at the other at a rate of 0.75 c. So I'm going to put 0.75 c here and say this is the speed of the missile as it leaves ship number 1. And the other observes it approaching it. So this one's kind of closing the gap at 0.95 c. Okay. And now we're into this question about which one is the u, which one is the u prime, and which one of the three speeds is the v. And again, if you watch that video, you will notice that I said there's kind of a natural one that you might call the stationary one, and I'll put in quotes, stationary. It's the reference place, and then the object. And I think in this case, the natural approach is to say that ship 1 and ship 2 are the observers, and the object is the missile. And just which is the reference observer, or which is the stationary one, and kind of picture yourself, I'll put here, and then this will be the moving observer, or what I call the non-reference observer. And so what this would do, if we pick these, and that was the emphasis of my other video, was it doesn't matter which one you pick as the object, and which one you pick as the reference, and which one did you pick as the non-reference. There's just three things, three objects that have relative speeds between them. Maybe I shouldn't use the word objects. There's three features that two of them need to be observers and one of them needs to be an object, and it doesn't matter which one you do, so maybe you ought to make it easier on yourself. But when it comes to being easy, you've got two approaches. You've got the conceptual easy, or you got the mathematical easy. Sometimes they go together, and if you watch my video on 21, they went together, and that was great. But 28, it didn't happen that way, and I don't think it's going to happen here in 29. Let me just start conceptually easiest. I think conceptually easiest is to think about the missile as the observer. Now, the reference person, 1 and 2, are probably about equal, but since I called it 1 and 2, I think it's kind of natural to go with number 1. So what that would mean, then, is u would be the speed of the object from the reference person. Okay, and so according to this description that is leaving, okay, what is the relative velocity of the two ships, or the unknown, if one fires the missile at the other at one fires a missile at the other at 0.75. So I think what they're trying to say here is this missile is leaving the ship at 0.75. So if you're in the ship watching it, you would see the object moving from your reference at 0.75, and it's going to the right, so I'll put a plus. And then the other observes it approaching. So if you are the other, if you're in this ship, the moving ship, the non-reference ship, and you look at the object, that's what u prime means. The velocity of the object is seen by this non-reference ship. And so it's closing the gap. It's coming in. And again, it's going to the right, so it's going to be a plus. And they said it was 0.95 c. And with this configuration, the unknown would be the speed of the two ships, the two observers. And that's what the v is in our understanding, is that v is the speed between the two observers. And that's what they ask. What is the relative velocity of the two ships? So when you write down this equation, u equals, and then we've got our v plus u prime over 1 plus u, or actually your book writes v first, but since I already wrote it, it doesn't matter what order, I'll flip the order. Okay, so u prime times v over c squared. You can see in this equation that if you know any two, you can find the third. So we know the u and the u prime, we can put it in and we can solve for v. But hence v is on the top and the bottom, there is a lot of algebra to do. So the algebra is a little bit hard, but the concept is a little bit easier. Now, we could switch that and make our algebra easier if we do this. And again, to help out, maybe I'll switch colors, but a second way of viewing this problem is to realize that in this algebra, the u is by itself and it's already solved. So make that the one you're looking for. So with that thinking, I would then call this the u. And for that to work, we have to call this then the object. So in green, I will call ship number 2 the object and ship number 1 the reference, which we already did the reference there. And then that makes the missile the non-reference observer, which, like I said, conceptually that's doesn't feel so well. You're like, oh, there's not like a person in there. But if you kind of imagine another person in there, you would say these two people are observing the motion of ship number 2. Because when you do that, the u becomes the unknown. Again, that it would be the speed of the object as seen by the reference. The u prime, which is the speed of the object as seen by the non-referenced observer. Okay, and so we've got a number of 0.95. Now we'll have to see which way it's moving, but I think they say here, and the other approaches to the other observer, it approaches at. So the gap is being closed up. And so if you kind of imagine yourself in this missile, you would kind of be seeing this closing up. And so it'd be like the object is coming towards you. That is, it's going left. And so that would be a negative 0.95. And so in this, like I said, weird view where you're thinking this is stationary and this is an observer and then this is the object, it would be coming this way at 0.95. And then the v is the velocity of the two observers here. And so here is our reference and our non-reference observer. And the v is the measure of those speed, 0.75, but it's as measured from this one. And so as you picture yourself in here, you would kind of see this other observer, the missile, going away from you to the right, so it'll be positive at 0.75. And so I kind of like this one. Like I said, this one I think conceptually is a little bit harder, but mathematically it's easier because watch this. If I just go to solve this one, I'll just say U equals, and that I can just plug this in. So this would be 0.75C plus a negative 0.95C all over 1 plus, and then the U prime is the negative 0.95C, and maybe I shouldn't have done green. I wonder how well green stands out in the video. I think it's okay. Where was I? Oh, U prime, and then times V, which is 0.75C all over C squared equals. All right, so on the top, we have, it looks like a negative 0.2C. And in the bottom, I guess I'll need a calculator for this. 0.95 times 0.75. 1. And I'll put the negative in myself. And my calculator gave me the 0.7125. But as you might have heard on my other video solutions, it's nice to list things in terms of the percentage of the speed of light. So those cancel off. And I think this is 0.8 something here, right? 1 minus the last answer, 0.875. Oh yeah, that makes sense, 75. And then finally, I can complete, oh, I guess I don't need a fraction. But I have 0.2 divided by that last answer. And so it's negative 0.695. And so I would say then we are, negative would be U. And so from this perspective, this one is moving negative. So we're closing the gap. And then that makes sense. That's the whole reason why this one looks like it's going away from it at only 0.75, but it is approaching this one faster because this one really isn't traveling quite as fast as that one. Now, just for completeness, maybe I'll come over here and show you where the conceptual one is easy, but the math is a little bit harder. And so if we plug this stuff in, we have 0.75C here for the U. The V is the unknown. The U prime is 0.95C. And then we get 1 plus, and the U prime is 0.95C. And the V is the unknown, and then C squared. That simplifies. We're going to have a few steps of math here, but let me cancel at least one of the C's, and we will get something like 1 plus 0.95V over C. Maybe jump to a clean page here. But I'll take the 0.75C and move the denominator over, 1 plus 0.95V over C, and then V plus 0.95C. Do a distributive property, 0.75C plus, and then when we multiply that out, the C's would end up canceling off. And we would have that same product of 0.95 plus or times 0.75, which is 0.7125, and then a V equals a V plus 0.9C. Now, if we do a little arithmetic and move this over to here, we would have the 0.75c minus 0.95c. And the same thing here, we bring that over, and we're going to minus 7125v. So that this becomes the minus 0.2c. And this becomes the 1 minus 0.7125. And that's the 2875v. And then finally, we can bring this to the other side and go 0.2 divided by that answer. And with the negative in front, we get 0.695, or rounded to 6c, which is the same as we got here. So again, your choice on how you define what is the u prime, or the v, but either way it works. And so you can choose to do the conceptually easy and mathematically harder, or the conceptually harder but mathematically easier approach. But either way, you should get the same answer. All right. Hope that helps. All right. Take care.